very good morning to you all.
Good morning, teacher.
Good morning.
Good morning, sir.
Good morning.
Morning, sir.
So we have a question here, guys. Although I said good morning and no one answered. Okay, like I said, good morning, teacher. Okay. Hope we are fine. I think you're enjoying curves, those of us who have been trying out numbers. No one has sent me any interesting curve they have landed on. Now, there is this one. It was, I think, either a mock question. It was looking funny as you see it. So the first question says, determine the nature. It was the second number. You will do this one. I'm giving it to you as an assignment. You try it out. Try 2007 paper 1, question 10. That is also your assignment to do. Now the first question here says, determine the nature of the turning points of the curve. Remember, I showed you that there are two various ways we can find the turning points of the curve. You can either use dy dx. So let dy dx is equal to 0. This is true for stationary what? For stationary points. So you will have dy dx will be equal to 0 times 1 plus x squared minus 2x times 2 divided by 1 plus x squared, assuming everyone is very comfortable with the quotient rule. So this will give us a negative 4x out of 1 plus x squared. And this turning point, when you equate this to 0, you will confirm that x is equal to 0. So if x is 0, what is y? Y will be 2 out of 1 plus 0. So y will be 2. So the turning point is at 0, 2. And it is only one. If it is one turning point, we need to investigate its nature, because the question wanted its nature. So go back to the neighborhood technique. This is 0, left of 0, right of 0. This is a constant. On the left of 0, dy dx, when you substitute, I told you don't bother with the denominator, investigate the numerator. So this is sine of dy dx. So the left will give me, the left is when you put a negative here, you'll get a positive. When you put here a positive, you'll get a negative. So the nature is maximum. So it's a maximum turning point. Okay, we have already got it. Second question, find the equations of the asymptotes of the curve. Yeah, so the asymptotes of the curve, 1, when you cross multiply, y plus yx squared is equal to y plus yx squared is equal to 2. Then you'll have yx squared plus 0x plus y minus 2 is equal to 0. Y is equal to 0 is the horizontal what? Horizontal asymptote. If you recall, the horizontal asymptote is attained by dividing everything by cross multiplying, and then you get the coefficient on x squared and equate it to 0. If one wanted to use the other technique of division by the highest degree of x, you would get 1 over x squared plus 1. Then when you substitute the limit as x tends to infinity, you will see that you'll have 2 out of x squared over 1 out of x squared plus 1. And this will give us 0 out of 0 plus 1. So you will see that our y tends to 0, which is exactly what I've just got. But remember, this is shorter, the second one, the first one. So we have got the horizontal asymptote. Now, remember, we are also supposed to investigate the vertical asymptotes. Vertical asymptotes, we equate the denominator to 0, if you recall. So 1 plus x squared is 0. You see that x squared is equal to a negative 1. This gives us x is equal to plus or minus I. Not so. Whereby this is not real. So it can't be drawn on a real plane. So it has no vertical asymptotes. The other option, all this I've done is I've used the longer method. The other option would have used this very equation and said yx squared plus y minus 2 is 0. Remember now here b is 0, a is y, c is y minus 2. So you would get from b squared, for the region where the curve does not pass, b squared is less than 4sc. So you'd get 0 is less than 4 of y into y minus 2. You'd get 0 is less than y and y minus 2. So the critical points become y is 0 and y is 2. Then you investigate. If you recall how to investigate, let me investigate this right here. I would investigate by investigating the regions of y less than 0, 0 less than y less than 2, y beyond 2. Then here y, then y minus 2. Then here you get sign of what? The function in terms of y. Less than 0, negative, negative, you get a positive. Between 0 and 2, 1, a positive, a negative, a negative. Beyond 2, positive, positive, positive. So the region where the curve does not pass, the region where the curve does not, the region where the curve is supposed to do what? The statement wanted, 0 is less than, it means y of y minus 2 is greater than 0. So we wanted a region which is positive. So you analyze that this region which is positive and this region which is positive, the curve does not pass there. Okay, So the curve only passes where we have the negative. So it passes only between 2 and 0. Elsewhere, the curve does not pass there. So we shade those two areas. Now, that is why this curve was interesting and I wanted to look at it. Whoever did not know how to go about such would not interpret the question rightly. So sometimes we can, if you don't want to shade, it's okay. But the shading just helps us to guide us how to sketch the curves, depending on the question. So not all the time that you have to shade. Some people are asking me, teacher, do we have to shade as a must? It's okay, you might not shade if you don't want. Now, this is y is 2. This is y is x is 0. So if this is the y-axis, this would be the x-axis. This is y is 2. This is y is 0. Remember now, we had seen that the turning point was 1. It was maximum. It was at 2. So definitely, because of this boundary 0, 2, when the curve reaches here, it has to turn maximum. But also we saw that the horizontal asymptote was y is 0. So if it's y is 0, when it approaches 0, it will become a rectangular hyperbola. Now, after turning here, but for those of us who want to shade, you should have shaded like this, that this is the region where the curve does not do what? Pass. And even the region below 0. So our curve is just passing in between those two regions. And to start with, the curve has turned here maximally at 2. After turning maximally, it comes down. As it comes down and approaches the x-axis, becomes asymptotic because that's a horizontal asymptote. You write it down that this is y is 0. The same applies this way. It comes down. It becomes a horizontal asymptote. So the idea, it forms what the normal distribution curve. You know the normal distribution curve from statistics, which we looked at, which we dealt with in probability density functions. Hence, that is our solution. So we have sketched the curve. So with those curves, we are ready to go for the oblique curves. The oblique curves, remember I told you, are those curves with improper fractions. Unless if someone has a special question of something, either on this one or whatever they have discussed before, and someone is not comfortable somewhere. Otherwise, if not, can go for the oblique curves.
Excuse me, teacher.
Yes, please.
There's this note I read that like the vertical and the horizontal at times you represent using dotted lines. I don't know where that one applies.
It is okay. To indicate asymptotes with vertical, with dotted lines. It is very okay. It's the same as me using different colors. But the most important thing about it is to scale, to label. You see, this is the x-axis, but I've labeled it as y is 0. Why am I labeling it? To confirm that that is our horizontal asymptote. So if you label them, the better. If you don't label them, we shall have trouble in illustration. So it is always good you label the axes, which are horizontal or vertical asymptotes, in the name of representing the asymptotes. Whether you dot them, that is okay. It's the same as saying, teacher, is it a must you should shade? No. But shading clearly shows you where the curve passes. But of course, some people will be like, me, I don't want to shade. Because me, I know where the curve is passing. It is passing here. So it has turned and gone down, asymptotic, gone down, asymptotic. This is a very correct curve. But it's just that some people, because they overcram, they might say, hey, but they say, if I don't see where the curve passes, I put a rectangular hyperbola. Then someone puts a rectangular hyperbola there, and this way, and this way, for no good reason. But if it is shaded, one will say, since it is shaded, nothing can pass down there. So that is the only reason why we shade.
Excuse me, teacher.
Yes, please.
Like on that very curve, I beg your pardon on how you've got the equation for the region where the curve does not pass.
Okay. Which region? Which equation? The one with the inequality sign?
Yes.
Hey, Aunt Kakati, do you remember how we get the region where the curve does not pass by investigating b squared is less than 4ac?
Yes.
That if b squared is less than 4ac, then that is the region where the curve does not exist, not so? Yeah, because in that case, you'll get a complex number because the b squared will be smaller than 4ac in the quadratic equation. You agree?
Yes.
Now, according to this equation, which I designed here, you see this equation? It has no middle term. The middle term was 0. That's why I wrote it for you here. You agree?
Yes.
So the b was 0. If the b was 0, that's how this equation came about. So I reinterpreted this equation and said, since 0 is less than this one, it means this term is greater than 0. So we want that region where that term is greater than 0. And that region is where we have the positives. But that region we want is where the curve does not pass. So the curve does not pass beyond 2 and below 0. That's why we shade it there.
Teacher, when we are solving, where does the 4 disappear from?
The 4?
Yes.
The 4, take it that it has been divided off. Okay? These are critical points.
Yes.
So there was no need of expanding because you find some people first expanding and then they factorize again. Yeah? So take it as that the 4 has been divided off. So the factors are y and y minus 2. All right?
Okay, thank you. Thank you, teacher.
You're welcome. Okay. So I was saying we are going for oblique curves. The oblique curve, we talked about it as a curve that has a slanting asymptote, or it has improper fractions. All those can be used to describe what this curve is all about. Now, let's have a look at an example. The definitions, we got them before. They can give you a question like this one. It says, given that y is equal to x plus 1 squared divided by x minus 1, and x is real. A, show that y cannot take on values between 0 and 8. B, find the nature of the turning points. C, sketch the graph of the function. Now, first of all, how do I know that the curve is an oblique curve, how it has slanting asymptotes, or it has an improper fraction? It should be in the form y is equal to ax squared plus bx plus c out of dx plus e. When the highest degree in x is greater than the highest degree in the numerator, is greater than the highest degree of x in the denominator, then we say it is an improper what? Fraction. All right? So according to that curve, it is an improper fraction. So the first thing they have said is to show that y cannot take on such values. In these curves, always don't waste time. Cross multiplication is the shortcut. Everyone should have that in mind. That for these curves, always we borrow cross multiplication. So we shall have y x minus y is equal to x squared plus 2x plus 1. And these curves never have horizontal asymptotes. Rarely do we have horizontal asymptotes here. Because when you cross multiply, also note, always no horizontal what? Asymptotes. The reason is you will not have the coefficient on x squared attached to y. Just like this one, you have x squared plus 2 minus y x plus y plus 1 is 0. This one has a coefficient 1. It is not in terms of y, so you can't equate it to 0 and say that y is this, so it always has no horizontal asymptote. But rather, we can investigate the region where the curve does not pass. Whereby b squared is less than 4ac for no real roots.
Excuse me, teacher.
Yes, please.
What about the division method?
We are coming.
Okay.
We are still answering what the question says. So we shall have 2 minus y squared is less than 4 times 1 times y plus 1. So this will give me 2 minus y squared is less than 4 into y plus 1. Then you get 4 minus 4y plus y squared is less than 4y plus 4. When you simplify, you get y squared minus 8y is less than 0. So y into y minus 8 is less than 0 at the critical points. So y is 0, and we also have 8, y is 8. When you see those values and they have been mentioned up there in the question, you just start smiling and say, I'm on the right track. So therefore, I can have y minus 8 sign of function in terms of y, then y less than 0, 0 less than y less than 8, y beyond 8. So with that reason, y less than 0 gives us a negative, and a positive. 2 positive, negative, negative. Beyond positivity, positivity, positivity. So the region where the curve has no real values, it was supposed to be less than 0. That region is where we have the negative, hence y cannot take on values between 0 and 8. Hence proof. y cannot take on values between 0 less than y less than 8. Okay. Now, that is the first question which they wanted. The second question said, find the nature of the turning points. Remember, when the curve meets this region where it does not exist, it turns. Okay, so according to that, you've seen that you have y is 8, you have y is 0, but the curve cannot take on values here, so you shade this part vigorously. So it comes from up turns minimally, it will come from down and it will turn maximum. So these points of 0 and 8, when you substitute them back in the equation, they should give you turning points. So for example, when x is y is 0, you'll get x plus 1 squared. X will be equal to -1. So you'll get -1, 0 is a turning point. But according to this interpretation, who is there? According to that interpretation I've given, Aisha Abdallah, how will the curve turn? What is the nature of this point, -1, 0? Is it maximum, minimum? Aisha Abdallah?
I think it's maximum.
Very correct, it is maximum. Then, according to this other one, when you substitute y is 8, you'll have 8 into x minus 1 is equal to x squared plus 2x plus 1, which will give us x squared minus 6x. -8 when it crosses over is plus 9 is equal to 0. And this is x minus 3 squared is 0. And this gives me x is 3 repeated, which means we shall have 3 and 8. What is Elizabeth Magala? Will that be a maximum or a minimum? Elizabeth, will that be a maximum or a minimum? Elizabeth? Namuri? Namuri? Naula, you give us the answer. What would it be? Habiba, give us the answer. Will 3.8 be maximum?
I've not got that part.
Pardon?
I'm not getting that part.
Which part?
For turning points, how are you getting them?
Hey. Do you remember when I said when you find the region where the curve does not exist, using cross multiplication method? You remember that technique which I talked about the lessons before?
Yes.
I said it can help you
Yes.
find over 5 things. One, it can help you get to know where the curve does not exist along y. That is one, which we have shown. Y cannot pass through 0 and 8. On the y-axis, secondly, it can get for you turning points. That if you have this upper part, which is 8 on the y-axis, when the curve comes and meets this 8, the line which connects the 8, remember this part is shaded, the curve can't pass through 8 and 0. The curve will just turn and go back. So it turns minimally on the upper region. When it comes from down and meets this boundary of 0 down this way, it will turn and go back. It will turn maximum. So you have got the region where the curve does not pass. You have got the turning points. 3, you have got their nature. Do you agree?
Yes.
4, you can get the x coordinates, which predicts the turning point itself, by substituting those y values in the general equation given and make x the subject, which I'm doing. We still together?
Yes, teacher.
So that's what I'm doing. And those are the things I've been mentioning all through, that whenever we come for this cross multiplication technique, be rest assured of the following. Oh, the other item we have missed is we also get a horizontal asymptote. If you recall, we get a horizontal asymptote from where? From equating the coefficient on x squared to 0, but you can't say 1 is equal to 0. It is impossible. It can only be equal to 0 if it is in terms of y. But now, because it is not in terms of y, it confirms that the curve never has a horizontal asymptote. But for the other general normal curves, you always get the horizontal asymptote if it is in terms of y. So those are 5 items which are discovered using cross multiplication. Other than that, you'll use the other traditional skills of finding everything one by one. Okay? Elizabeth Hamaik has a problem. Then give me the answer in the chat, Elizabeth. 38 is what? Minimum, maximum. So now, Habiba, can you now give me the answer?
It's a minimum.
Okay, hope you've understood very well. Okay. The next question was saying, get the turning points. We have got them. Their nature, we have got it. Next point, sketch. We are ready. I've told you with this curve, just use the cross multiplication, everything will be okay. Maybe there is only one asymptote. We have a vertical asymptote. Because the curve was y is equal to x plus 1 squared over x minus 1, the vertical asymptote we equate the denominator to 0. So we only have one asymptote, which is equal to x is equal to 1. Okay. If someone wants to investigate intercepts, okay, you go ahead. Intercepts. When x is 0, what is y? Y is -1. Okay, 0, -1 is an intercept. When y is 0, we have already seen this is an intercept and it's a maximum turning point. Hence, sketch the curve. So we are going to sketch the curve. It has 3, 8, -1, 0. Okay. Our vertical asymptote is
Teacher,
x. Yes, please.
aren't you getting the slanting asymptote?
Oh my God, thank you so very much. I don't know how I missed that. And someone asked me about it and I forgot. Sorry. We don't have a horizontal asymptote, but we have a slanting what? Asymptote. Thank you. By long division. So we can do long division here. X squared plus 2x plus 1, x minus 1. You get x minus 1 squared minus x. When you subtract, we shall get 3x plus 1, so plus 3. So you get 3x minus 3. The balance is 4. So y is equal to x plus 3 is the slanting asymptote. So the quotient you get on long division is the slanting asymptote. And by now, I expect everyone to be an expert in coordinate geometry. When you're sketching that line, you just investigate the asymptotes. When y is 0, x is -3. When x is 0, y is +3. Okay? So let us sketch. If this is our curve, This is our asymptote, which is a vertical asymptote. Now, let us first note these items. Don't worry, in sketching, you don't need a ruler. May I just want to be a little bit more perfect, but you don't need to have a ruler. This is x is equal to 1, vertical asymptote. This is y is 8. This is y is 0. And at the same time, this is x-axis. But we have said in this region where y and x and 8 exist, the curve does not think of passing there at all. I can shade there vigorously to show you that the curve can never think of crossing this region. Now, this is 0. We have said when x is equal to, look at now our slanting asymptote. When x is 0, y is 3. Y is 3 is here. This is 8. When x is 1, when y is 0, x is -3. X is -3 can be here. Then we can have our slanting asymptote. Let me use red line to show the slanting asymptote. Okay. Okay, I'm going to change this 3. Maybe it is so close. Okay, so with this, let's assume this is where our -3 is. Let's assume this is where our +3 is. Now, if this is 1, our vertical asymptote, the curve is having a turning point of -1, 0. You remember? This is -1. So I can have this as my turning what? Point. Then also, remember this one, it turns maximally. Yeah? It also has a turning point this way of 3, 8. So here where it's turning from, I'm assuming there is a 3, so I can label this as my 3. It is okay. It is as long as consistency is there, that from 0 you go to 1 to 3, we have no problem. Now, this is what is going to happen. After the curve has turned here maximally, it's going to come here and become asymptotic to the curve. Okay? When it goes, it is going to be brought back by the same curve on the other side. So it has been brought back by the curve, by the asymptote, which is the slanting asymptote. When it arrives, it is going to turn how? Minimally up here. Then after it has turned minimally, it's going to turn and go back and follow the vertical asymptote. Then it becomes asymptotic again, up to the sky. When it goes that way, it's going to be brought back on the opposite side by the vertical asymptote. It is bringing it back. When it brings it back, we have an intercept on y, which is 0, -1. So we can indicate that it can come and turn here maximally. After turning maximally, it comes and crosses here, meets -1. When it meets -1, it goes down and becomes asymptotic again. Hence, that is the solution to our curve. So this is our line. Y is equal to x plus 3. This is our curve. Y is equal to x plus 1 out of x minus 1. But when this is square. So you can see clearly everything has been labeled. We have our line here, y is 8, our boundary. We have our boundary here, y is 0, which is also an intercept. So with that, we would have been in position to identify clearly how the oblique or the slanting asymptote curve can be sketched. Questions before we proceed? We're about to be lucky. We could finish the entire topic today. That is if we sketch the last one. Yes, any concerns? Anyone with a question? There is a number I sent. There's a number I sent among the numbers I sent, which has x squared over plus 2x over plus 1 over 2x minus 1. That number, you should all try it out. And you should send it to my WhatsApp. Send it as a PDF for my marking. Some of you never sent the work. I don't know what's wrong with some people. Those of you who are offering physics and math, some of you never sent your work. And I want that work in terms of PDF in my WhatsApp box, because I'm using the application which is requiring such a format of sending work. Okay, any questions on this number? The oblique curve. I've told you you have an assignment of the number that I sent you. You should try it out. So I want to look at the last bit, which is reciprocal of the curve, and we finalize. Then we shall know that curve sketching, you are ready to attempt any number. I told you there are easy numbers, but you should not overrush them. That is why I encourage learners to do them as number last rather than as number one. Because if learners do it as number one and they make an error and the curve does not become continuous, people get into trouble. Okay, can I flip the page? So the last bit of curves is what we call the reciprocals of curves. They tell you to plot one out of f of x. You have one out of x. They can even tell you to plot them on the same graph. The reciprocal curve. In brackets, y is equal to 1 out of f of x. Y is equal to 1 out of x. Consider a curve whose equation is y is equal to 1 out of f of x. When the graph of the function f of x is familiar with the following, simple properties. Provide means to adopt or to adapt the curve. Find means to adapt the graph of f of x to obtain the reciprocal curve, which is y is 1 over f of x. So note the following. First and foremost, for a given value of x, f of x and 1 over f of x have the same sign. Then 2, if the numerical value of f of x increases, 1 over f of x decreases. 3, if f of x tends to plus or minus infinity, 1 over f of x tends to 0. And if f of x tends to 0, then 1 over f of x tends to infinity, positive or negative infinity. Then also, if f of x has a minimum point, one over f of x will have maximum point. At the same value, of x. And if f of x has a maximum value, a maximum point, then 1 over f of x will have a minimum value at the same value of x. So those are the keynotes we should note. 1, we have seen that 1 over x and f of x, 1 over f of x and f of x have the same sign. 1 over negative 2 is the same sign as negative 2. Then if you have a numerical value of f of x increasing, then 1 over f of x will decrease because the denominator becomes bigger. A bigger denominator brings about a smaller value. Then as f of x tends to infinity, 1 over f of x tends to 0, and the reverse is true. As f of x tends to 0, 1 over f of x tends to infinity, positive or negative. If f of x has a minimum point, then 1 over f of x will have a maximum point, and the reverse is also what? True. So we should have all those items in place. So let us have our last example of curve sketching, considering all these items. So here we are. An example on the reciprocal curves. Sketch the graphs of the following functions. Sketch the graphs of the following function. I think the rain has also arrived at your places. Let's hope it will not interfere our number. Yes, Lab Abe. Is your hand up?
Sorry, sir, it is a mistake.
Okay. So I was saying, the question says, sketch the graphs of the following functions. F of x is equal to x squared into x plus 2. And g of x is equal to 1 over f of x on the same axis. Show the asymptotes and turning points. So to start with, let us start with f of x, which is x squared into x plus 2. 1, the intercepts, when x is 0, of course this is the y. Y will be 0. So the curve cuts the y-axis at x is 0, which is the origin. When y is 0, that is if f of x is 0, then x is 0 and x is negative 2. So we have the points cutting the values at 0, 0 and negative 2, 0. Furthermore, you can get the turning point. This time around, you have to use dy dx to become what? Product rule. You get x squared times 1 plus 2x into x plus 2. But it has to be equal to 0. This is for turning points. That statement should be written there. So x squared plus 2x squared plus 4x, 0. Then with that, you have 3x squared plus 4x is equal to 0. And x will be 0 or 3x plus 4, 0. So the turning points would be x is 0 and x is equal to negative 4 over 3. Because we have already seen x is 0 as its turning point, we need to find the corresponding y value. When x is negative 4 over 3, it's 16 over 9 into negative 4 over 3 plus 2. It will be 16 times 2 out of 27. 32 out of 27. So you have points which are x is 0 gave us y is 0, which is 0, 0. Then you also have negative 4 out of 3 and 32 out of 27. But for these ones, we don't know which one is maximum or which one is minimum. You can either use second derivative or you use neighborhood. So if I'm to use neighborhood, they use second derivative. I think let me use second derivative for the first time. But the other ones
Excuse
never
me,
use
teacher.
second derivative. Eh?
Pardon, sir.
I have substituted.
Uh,
Where?
Oh, how have you come across with with 3x squared plus 4x is equal to 0?
And I differentiated this function using product rule.
Okay.
Then I equated to 0. I first differentiated the bracket, I got 1 times the x squared, plus differentiate the x squared, keep the bracket constant. Then algebra is equal to 0. Then I factorize. Okay? Then I found the values of x, which when substituted back, I get their corresponding y values. So I got the point. Now I need to investigate whether those points are maximum or minimum. And I wanted to use second derivative. If I differentiate the second time, I'll have to differentiate with respect to x. I'll have to differentiate this one. The 3x squared plus 4x. When I differentiate, I get 6x plus 4. Now substituting 6x plus 4. 1, put there x is 0. When you put there x is 0, you get a positive 4. Positive calls for minimum. So this is a minimum. Then also 6x plus 4, substitute there x is equal to negative 4 out of 3. What do you get? You'll get 6, which is 24, a negative, out of 3 plus 12 plus 4. You'll get a positive, a negative 12 out of 3, which gives us a negative 4, which corresponds to maximum. So this is a maximum turning point. If you're not comfortable with second derivative, go and investigate using the neighborhood. That one you'll check in your free time. But I was just showing you that even this option can work. Okay, now because also that option can work, we are good to go and we can be in position to, having gotten the neighborhood, asymptotes, as x tends to infinity, even y tends to positive or negative infinity. Okay, so because it is just one simple, it is not a fraction. Now, for the horizontal asymptotes, now that is for the first curve, this one. Now let me sketch the curve here. This is my y-axis. This is my x-axis. The curve has this as 0. This is y-axis. This is x-axis. So the turning points are what and what? We have negative 4 out of 3. Okay, you are here. And what else? And positive 32 out of 27. Positive 32 out of 27 is some value here. So here the curve turns how? Maximum. So having seen the curve turning maximally there, it also has a what? An intercept. Where is the intercept? The intercept is here. The intercept is somewhere around here. where it is when x is 0, the intercept is at, we have 0, 0. 0, 0 is also a turning point by the which is minimum. So here, if the curve has turned maximally, it will come and turn minimally here. Then it will go that way. Then after turning maximally here, it will come at the intercept here and go this way. So these are the normal senior 5 curves, the first curves you studied just after differentiation. But now, when y is 0, we have seen the curve cuts the x-axis at x is -2 and x is 0. So this point is -2. Now they are going to ask you to sketch on the same graph g of x. Now g of x changes things. We shall come back to the graph. Let us first glance what g of x is. So g of x is 1 out of f of x. Do you see that it's 1 out of x squared into x plus 2? The other one we saw, it never had asymptotes which were either standing or whatever the case. So in this case, this one has vertical asymptotes, which are got by equating the denominator to 0. So x is 0 is a vertical asymptote, x is -2 is a vertical asymptote. That is 1. Then 2, it also has horizontal asymptotes. Horizontal asymptote can be got by our y now is going to be 1 out of x to the cube plus 2x squared. Remember, we divide through by the highest degree of x. You get 1 plus 2 out of x. In the limit, as x tends to infinity, of y is going to be equal to the limit as x tends to infinity of 1 out of x cubed, all divided by 1 plus 2 out of x. This tends to 1 out of infinity out of 1 plus 1 out of infinity, and this is 0. So y tends to infinity to 0. One might say, me, I want the previous definition, teacher. Cross multiplication is my work, is my thing. Cross multiply. Y x cubed plus 2y x squared is equal to 0. Me, I use Cramer's rule. I cram all the time. The highest degree, which is x cubed, the coefficient on it equated to 0. Y is equal to 0. It's the horizontal asymptote. Same answer. So don't cram so much. Those of you who cram and always say it has to be x squared. Teacher mentioned x squared in the notes. No. We define using the highest degree of x. So the highest degree this time round is x what? Cubed. Okay. So we have a horizontal asymptote. We have a vertical asymptote. They are actually 2. Now, the concept also is on turning points. Remember, I told you the turning points also matter. Yeah? We said where it has a minimum turning point, this one will have a maximum turning point. Okay? So, remember, we say the turning points now become what? Turning points. So, you don't need to go ahead and differentiate again. Yeah? So, we shall have, we have, the curve has no maximum, because initially we had this one. Let's go back. Initially, we had this one as a maximum turning point. Okay? So if this was a maximum turning point, the value of -4/3, which is there, should give us the minimum turning point for our curve of 1 over f of x. So let's check. But before I can check that, remember the other one was 0, 0. So because it was 0, 0, when you substitute 0, 0 here, you'll get 1 over infinity. So g of 0 will give us 1 over 0, which is infinity. So it has no maximum turning point. Why am I calling it a maximum turning point? It is because where 0, 0 was, it was a minimum turning point. This was a minimum turning point. And remember, I said if this gives you a minimum, the other one gives you a maximum in the notes. So because we are looking for the maximum of the other one, which is supposed to be at x is 0, when you substitute x is 0 is in the other equation of the reciprocal, we are seeing we are getting infinity. So it has no maximum turning point. Now let us check when we substitute in this maximum turning point where x is negative 4/3. When you take it to the reciprocal, what value will it give us? Let's go and find the reciprocal. So g of negative what? 4/3 will give us 1 all over. The other one was 32 out of 27. 1 over 32 out of 27. So this gives us 27 out of 32. So this becomes our minimum turning point, which is negative 4/3 and 27/32. If you're not comfortable with those definitions I've mentioned, then go back to basics. Do everything normally, the way we do things. Simplify everything slowly by slowly. Go on and simplify and do whatever you have to do to get everything. But because of those notes I've given in this case, you can summarize the procedure. So with this, we are ready to sketch. So we have to sketch this one on the same, meaning where the other curve passes, also this one can pass. Now, in that sense, let's go back to the graph. Going back to the graph, first of all, we have identified asymptotes as x is 0 itself is an asymptote. So if x is 0 is an asymptote, I can sketch it here like this. Let me attach a line here. So this is x is 0 is an asymptote. That one is an asymptote. And I can extend it and I say, this is my x is equal to 0 to indicate that it's an asymptote. So I can write it down. This is x is equal to 0. The second asymptote was x is equal to negative 2. Let me use green for all the asymptotes. X is equal to negative 2 is right here. X is equal to negative 2 is an asymptote. Then we also had the horizontal asymptote. The horizontal asymptote was y is 0. The horizontal asymptote is actually the x-axis. Now they have said, because those are asymptotes, our point which we had initially as negative 4/3 and 32/27 has turned to become 27 out of 32. And it is somewhere around here. And it has become a minimum turning point. Let me use blue. So it is going to turn now minimally. No longer turning maximally. After it has turned, it becomes asymptotic. After it has turned, it becomes asymptotic. So when it becomes asymptotic, this is what is going to happen. We form a parallel line up to infinity. You also form a parallel line up to infinity on this side. Now, because of that, if I was to investigate the region, you see now, people are saying, teacher, are we supposed to sketch, to shade all the time? No. Why? Look at what is going to happen. This asymptote x is -2 has taken the curve to infinity. It is going to come back through this way. See? It has come back. On coming back, as it is arriving, this is what is expected. It is going to turn because it is meeting an horizontal asymptote. When it meets this horizontal asymptote, it becomes asymptotic again, horizontally. And it goes to infinity. Now, then it will also come back through this side. When it comes back through this opposite side, it's coming back through this way. When it comes back through this way, it is going to turn asymptotically, and it is going to go up like this. So you will see that it will come and turn from here. And then it proceeds. So with that, you will see that if you're to shade where the curve does not exist, the curve will not exist here. For those of us who are good at shading, the curve will not exist down this way. That is why I told you they have the same sign. So if you're to go on and investigate the other table of ours, it will clearly show you where the black line has passed is where the curve passes. Where the blue lines of the curve have passed is where the curve passes. So these other areas, the curve does not pass there. So if you can shade. If you don't want to investigate the shading, it's okay. So that is what happens. And now this will be our curve. Y is equal to x squared into x plus 2. Whereas this one will be the reciprocal of y, which is 1 out of x squared into x plus 2.
Excuse me, teacher.
Yes, please.
So in a paper,
Yes.
we have to do all this in pencil.
No, you can use pen. As long as it's not red, it's not green. Blue, black, blue, black, yeah. Okay.
Okay, thanks.
This was a unable number. About which year, I don't remember. It was a unable number. So they could ask people to draw. So even if you did shade, but you brought out the sketch like that, it would give you your marks. All right. Any other question?
So could you go back to the previous page?
Okay, there you go. Just know those reciprocal curves share some of the items. They share signs, they share regions where the curve pass. When they share the sign, they share the same region where the curve passes.
Okay, so thank you.
You're welcome. So any other questions, guys, on curve sketching? Otherwise, we are done with curve sketching. I'm happy to announce end of curve sketching. So every curve that you land on, you should be able to sketch it. So we shall put more energy on, although we are soon having our holidays. Very soon, we are having holidays next week. I mean, on 11th. Now, next week, what I will do, tomorrow I'm starting on a parabola. Next week, I'll start on an ellipse in this lesson, so that I drive them concurrently. So that for the remaining 2 meetings, we shall have whatever we shall have done. If time allows, if we can allow a ball sometime and we finish conics, well and good, but I know most of you are tired. So I'll teach as far as we can. Okay. But at least tomorrow I'm starting a parabola. Then next week in this lesson, I'll teach ellipse. Then on Tuesday, I finalize with parabola. Wait, well, oh, you have another lesson immediately after this one, eh? Or you first rest? I think
The other lesson is that two.
here you have economics. Okay. Kale, please, any further questions you always have in curve sketching, don't hesitate to reach out to me.
Excuse me, sir.
Yes, please.
Sir, I please beg your no. Help me like to go back on the previous pages.
The other pages of the first lesson, of the first curves.
Yeah, the slanting curve.
Yeah. The slanting curve. We had interruption with network, so I got it and put it somewhere here. I have it, but let me see if you can have it. I'm also going to upload this video, both of these videos, but this first video, let me see if you can do it from this first video. This one is dying.
So which chapter in Backhouse can I find numbers on?
Backhouse 2.
Which chapter?
Which chapter? You can it is just there close to the first pages. Here is my Backhouse 2. Okay, we shall screenshot.
Okay, thank you.